let's get started. So validation engineering is it's an entire kind of discipline, I guess. So I'm not going to be doing a tech talk on the discipline, but rather one specific project under the discipline of validation engineering that we spent a good amount of time working on WATonomous, and that is how to make our track days productive. So I know a lot of you aren't familiar with this because all of the content I'm going to be going over here is from a year ago, which is May 30th was the last time we had an actual track day. Wait, sorry, can you guys hear me?
Yes.
Yep.
Okay, cool. Yeah, so a track day is basically when we want to test out some autonomous features on the car. We go to our private test track up near the boardwalk, and it's a lot of like cost to do that. Maybe not monetary cost, but like it takes a full 12 plus hours out of people's time, and it's a big portion of the team working towards this. So if we have an inefficient day, it really like is harmful to the team. So we've put a lot of engineering work onto how to maximize the efficiency. And so steps to, is this my first slide? There's no slide before this, just to confirm that.
Yeah.
Okay, cool. So yeah, how do we take steps to be efficient and have a successful track day? First step is to identify the resources that are required for the track day. These include physical resources, software resources, and also human resources. Once we've identified those, we want to set up protocols for like initializing the track day. So maybe having something like a staging or dry run day, pre-briefing to go over logistics, and also pre-checks to make sure that the vehicle platform is all set. And then finally, in step 3, we actually get to the track day itself, and the instrumental tool there is the test plan, which should be scheduled. It should be easy to follow. It should have well-defined data collection steps. But after we're done at the track, after we're done following the test plan, the work isn't done yet. It's very important to have a teardown protocol, including a post-briefing and post-checks. So yeah, we'll quickly go over each of these steps and how we implement them on the team. Next slide. Okay, so first was identifying resources. This is basically just taking an inventory of what we need for a track day. But again, it's not just like physical resources. It's also human, who's going to be taking on which role. Obviously, we need a trained safety driver. We need pipeline operators that are experienced in the different parts of the pipeline that we want to be testing. We need crew members just to support setting up the physical infrastructure, et cetera, et cetera. So taking an inventory of people, also an inventory of which sensors need to be functional. Maybe we don't need the radars for a specific test. So if they're undergoing some development and aren't functional, that's fine. But maybe we do need the radars, and then we would need a check to make sure that they're ready to be used for the track day. We also take an inventory of the physical testing equipment we need. So this is stuff like intersection signage, stop signage, calibration, checkerboards, the guided soft target eventually, and the pedestrian dummy, et cetera, et cetera. And then the last kind of resource that comes to mind is software resources. So making sure that all of the Docker images that we're going to be running that make up the pieces of the autonomous stack that we're testing have been pulled to our compute platform. We've checked out the correct repository branches. We're on the right commits, et cetera, et cetera. And yeah, so any questions about that first step in having a successful track day?
Hi, Rowan, can you hear me?
Hey, yes, I can.
So how do you test that sensors are functional and that they're working as you expect and as you need?
Mainly just turning them on and then Ross topic echoing the corresponding driver output.
Okay, makes sense.
Yeah. And then during the staging day that I'll talk about next, maybe we go into a little bit more testing of them to make sure that they're working with our baseline perception algorithms. But from an inventory perspective, it's literally just like, are they mounted on the car? Because I mean, as you guys have seen, sometimes we have problems where we come in and someone took the LiDAR off for reason XYZ. So just having like a inventory that everything is in the place that it should be is a important step.
Right, just having like a checklist that we make sure all the boxes are checked for, just for the bare minimum things that we're going to need.
Yeah. All right, and then step 2 was having a setup protocol. So an important part of this is having a staging day, which is we call it like a mini track day, usually a day or two before the full track day. And this is a very low cost event. The whole reason of it is it's a low cost way to make sure that we don't spend a lot of cost at the full track day for no reason. So for example, for the staging day, we might realize that our compute platform has a fatal flaw and we're never going to be able to complete the track day. And we spent a lot less cost to figure that out than going to the main track and figuring it out there. So basically the idea is to confirm that we have a baseline vehicle platform that we can do anything with. Once we've confirmed that, we also have a pre-briefing, usually like the night before the track day, which we review the schedule, make sure all the stakeholders are on board with it. The schedule is on the test plan that's on the next slide. And then we finalize stuff like, oh no, sorry, still on the previous slide. We make sure that we finalize all of the logistics, like who's taking what car, et cetera, et cetera. And then we have another checklist, which is pre-checks. So this is like, it requires that all the inventory is in place, but it goes a bit further than that as well, doing very specific checks that our baseline software infrastructure is set up correctly, CAN is set up correctly and working. So you can see some examples of the pre-checks in this figure here. So yeah, I guess here's the procedure for testing sensor functionality, Arjun, to answer your question.
Okay, thanks. Yeah, verify all required sensors are present and mounted. That is important.
Yeah. Then verifying all the sensors are publishing to the correct topics. And again, all of this could be done at track day, but if we try to do all of this on track day, we wouldn't get much actual autonomous testing done. And we would probably run into a problem that we would then spend all of the track day trying to fix instead of doing the actual tests. Any questions about this setup protocol?
So it's like testing on local before pushing your code to production, basically.
Exactly, yeah. Okay, so after all this, we're finally ready to move on to what we actually do at the track, which is defined in our test plan document. So the two important pieces of each item on this test plan is, first of all, accurate scheduling. So we want to plan out realistic time slots with added in buffers for context switching time. If we only get done half of the test plan, I wouldn't say that's a successful track day. So we want to be realistic. And the other thing is all of these line items should be easy to follow. It's the pipeline operators that are going to be executing each test. So making sure that the pipeline operators that we identified that are going to be at the track are able to follow the initial condition setup, the testing procedure, and look at RViz for the observed expected outcome, and also know exactly what data should be collected. Because a lot of the time these tests, these line items are executed by not the main developer on the modules that are actually being tested. So yeah, things can easily go wrong if it's not laid out in an easy to follow manner. Any questions about the test plan? All right, so last but not least is having a well-defined teardown protocol. So this is similar to the pre-checks, but basically tasks that need to be done to get the bolty and the bay back into a good state so that they're useful going forwards. By useful going forwards, I mean if we collected all of that data on the test plan, but then we just leave it on the hard drive of the rugged compute server, that's not that useful because we want to run it, on all of our powerful VMs and have all of developers have access to it. So making sure that we put the data in the right place and broadcast to the right stakeholders the location of that data, so that we're in a good state going forwards. And also stuff like making sure that the power supply has been transferred over to wall power correctly, cleaning up after yourself, etc. Then debriefing is the last step. This is basically reviewing what we can do better for next time, because what inevitably happens when you're at the track, you think of dozens of things that, oh, we should have prepared for this contingency, or we should add this to the inventory list to check before coming because we forgot something. So the debriefing is a time to kind of go back through that mental laundry list that came up at the track day and actually record all of these action items. Yeah. Any questions about tearing down?
So the main goal of debriefing is just so that, because if we don't write stuff down, we'll probably forget, right? So that's just so we have like paper memory of stuff for further iterations.
Exactly. The best time to take actions on something is when it's fresh in your mind and you actually feel passionate about it. Within 12 hours of going home and sleeping and waking up the next day, I probably will forget / don't feel as motivated to fix up the things that went wrong, and they'll only bite me in the butt again 2 weeks later. All right, well, thanks for listening. Hopefully this was useful to yourself and also to the team once all of you inevitably become an integral part of successful track days.